3.0b, we're also about having variables on both sides, but now we're going to maybe have some steps, extra steps to do at the beginning, even before we look to get the variable only on one side. Like in example 1 here, looks like we have some parentheses to clear on the left side. So before we do anything else, we clear the parentheses via the distributive property. Now, what are we distributing here? I usually look at it as just we're distributing a negative sign. It's technically a -1, you could say it is. And so when you distribute that to the x, we get -x. And when we distribute that to the +2, we get -2. So that's what we get when we clear the parentheses with the Now we look at this and go, are there any like terms to combine on the left already? Can you do any combining of like terms on the left? No. Can you do any combining of terms on the right? No. So now it's time to get the x only on one side and then get that x all by itself. Now, I could either subtract 3x so that it ends up over here and we're getting our x's together over here, or I could make this -x go away from the left so that we can gather our x's on the right. Now, if you're following the priority of I really don't want to have like negatives on my variable, well then you pick the -x to attack, the smaller one, and what's going to undo and get rid of -x is adding x to both sides. Remember, whatever you do to one side, go to the other. So that makes that go away. So it looks like we're going to gather our x's on the right. And so we have -2, and then 4x plus x, or sorry, I think I misspoke there. Getting a little ahead of myself. 3x plus x is 4x. So that's the right side now, 4x minus 8. And now you just kind of, I might run out of room here, but so now we look to get get the x all by itself. -2 plus 8 is 6. And then we look to divide both sides by 4. And so let's go over, up here a little bit, whatever. And x will now be alone on the right side. And then what is 6 divided by 4? I guess you could say that as a decimal, 1.5 or 1.5. But 6 over 4 you could also leave in fraction form, but it reduces to 3 over 2. Again, 3 over 2 is equivalent to the decimal 1.5, and especially since 1.5 is exact, like you didn't have to round anything to get a decimal of 1.5, I'd be totally okay with 1.5. It's a little, at least a little more likely that you should be ready to have your final answer be in a fraction like 3 over 2 and not 1.5. But they're both good, especially in this case. Number 2, same deal, right? Don't we have to clear the parentheses before doing anything else? And when we distribute the 2 times x is x, 2 times +7 is +14. The left side is, still x plus 19. And now we look to, get the x's only on one side. Let's do it this way now, where I want to gather the x's on the left, and so this 2x on the right needs to go away. And so, well, over here, what's x minus 2x? It actually turns out to be negative 1x, or negative x. Over here, we just have a 14 now. And so now, looking to get x all by itself, we get rid of that plus 19. And so we have negative x equals, what's 14 minus 19? Negative 5. Okay, I kind of wanted to get to here. Now remember, this technically is a negative 1x. So what's the final thing you do? Because we're not done. You can't stop when it says negative x equals negative 5. Technically, you want to divide both sides by a negative 1 to leave just x on the left side. And then negative 5 divided by negative 1 is, well, come on, board and pen. Positive 5. The final answer is x equals positive 5. 4 more examples. Okay, what do we do in number 3? There's no bubbles to clear, but I do look at the left side and see a couple of like terms. They're already on the same side as each other. So you would just combine them. 5x minus 6x is again negative x, or negative 1x. Minus 2 comes down, equals negative 8. And so from here, we would then look to get that x all by itself. Negative 8 plus 2 is negative 6. And then see, technically, we would now divide both sides by a negative 1 to make negative x just x. And then negative 6 divided by negative 1 is 6. Number 4 is like the same thing. 5x minus 2x, that's already on the same side. 5x minus 2x is 3x. And so now we just work on getting that x all by itself, like we've done 100 times by now at this point. Last thing to leave x all by itself is attack the 3 to get x all by itself, and so x equals 2. Number 5, man, we're not seeing a whole lot of new stuff. So just a lot of repetition here. Looks like, well, what's going to happen in number 6? Well, okay, not really much different. So again, just kind of keeping in mind that if there's any parentheses to clear, you do that first. Then you look for, and there's none of that in number 5. So what we look for next is there any like terms that we can combine all, as they are, because they're already on the same side. Like this 7x minus x. That's 6x. 7x minus, remember there's technically a 1 right here. So 7x minus 1x is 6x. Plus 3 just is on that side as well. So bring down the plus 3. Bring everything else down. Keep everything lined up. Alright. And now we can look to attack the plus 3. And then attack the 6. Whatever numbers are crowding the x, that's the numbers you attack. Right? Looking back up to here going, let's subtract 21 from both. No, what? Don't leave the 21 alone. It's this stuff that's crowding around the x. I hate it when I see that. Subtract 21 from both sides. No. The whole idea is to get rid of the stuff that's crowding the x on that left side. Come on. Final example here. Well, we can do the 4x minus 2x. That's just 2x. Everything else comes on down. And looks like we need to get the x's only on one side. So I'm going to subtract x from both sides so that we only have one x, or x on the left. And we still have a positive 111. And now we look to say, again, it's like, let's subtract 111 from it. No! It's the plus 6 that needs to go away so that x is by itself. So we subtract 6 from both sides. And that is what's going to get x alone and on its side of the equal sign. And so 105, if I'm not mistaken, is the final answer. Oh yeah.